Um, we, okay, well this is going to be my semester of pre-calc
Okay.
that I have to take. But right now, it's, like super easy. We're just doing, well, we got our first real homework assignment today, and it was just like, functions and inverse functions.
Okay.
So I don't really think I need to do that. So I was wondering if instead we could do SAT practice.
Okay.
Because I think that's what I should focus on.
Okay. When are you taking the SAT?
There's one available for me in April and another one in March and one in May.
Okay.
So I took the PASAT already,
Uh-huh.
and I did well on it except for in math. In math I was like in the 80th percentile.
Okay.
And I think it'd be good to be a little, well, it would be good to be a little higher.
Okay.
So that's what I want to focus on.
Let's see what I've got here. I've got, this is the best SAT stuff I have. Have we worked on SAT before?
We've done SAT or ACT, I don't really remember which one.
I know we've done ACT.
Oh,
Here,
yeah.
I have a note here that says we did SAT a couple of months ago, and we got to number 10 on page 281. So, now, I can't be certain that my note is current, so we may have done these already. And if you recognize that, it's harder for me to recognize it because I end up doing these with a lot of students. But if you feel like we're going over problems that you've already gone over, please say something.
All right.
So my note says we got through number 10 here. Let's start with number 11.
Okay.
How are we going to do this problem?
The area of a circle, pi r squared. So, I could back solve maybe for the radius?
No, conceptually, how are we going to do it? Shaded region problems are always what?
Subtraction?
Yes. So what do we need to subtract from what in order to get the shaded region? Now they want the circumference of the shaded region, which is a little different than the area. Usually they're asking for area of the shaded region. So the circumference is going to be a little different. However, the one thing about circles is that radius tells you everything. If you know the radius of a circle, you know its area, you know its circumference. Likewise, if you know its area, you know its radius and its circumference. In other words, you only need to know one of the three things, and you know everything there is to know about that circle. Okay, so if the area of the larger circle is 25 pi, what is its radius?
Okay. So, I'm so bad at circles. The area of a circle is pi r squared, right? Yeah.
And what's
then,
what's the circumference of a circle?
25.
No. There's only two formulas you need for a circle. Pi r squared, and what's the circumference, the other formula?
The
2 pi r. It's the same. It's the same three numbers.
Yeah, I like the diameter.
In other words, just bring the 2 down in front. It's kind of like taking a derivative. Okay? So, and that's why I don't use the diameter. I prefer radius because radius is the key thing for calculating everything. All right, so what is the radius of this? If 25 pi is equal to pi r squared, what's r?
5.
Okay. So from O to D is 5. What's the radius of the little circle?
Half of 5, so 2.5.
Now, what is the circumference of the little circle? Since that's going to be the distance around that right there.
10 pi?
It's 2 pi r of the little one.
Oh, so 2 pi 5? Wait, 2 pi r.
Right. So the circumference of the small circle is 2 pi times 2.5, so that's 5 pi. The circumference of the large circle is 10 pi. What is the perimeter of the shaded region?
The shaded region?
Huh?
Wait, what are we solving for?
What is the circumference of the shaded region? Now, normally shaded region problems are area. This is a little different.
So we're looking at it.
The circumference is the distance around it. So if I'm looking at the shaded region and I want the circumference, well, I can start there. I could go all the way around. That's one circumference. And then I need the circumference of the inside circle also. So the circumference of the shaded region is the circumference of the small circle plus the circumference of the large circle.
Okay, now I get it.
Okay.
Sorry, I don't know.
Okay. So that's 15 pi. Okay. So the key to this problem, this is a fairly difficult problem, but it's really all about, if you know radius, you know everything. You know the areas, you know the circumference. You can figure out anything you want once you know the radius. Number 12. Ooh. 1 comma a. This is a linear function. What does that mean?
That it's a straight line.
Okay.
Right.
Uh-huh. And they want to know what is 3/2 times b minus a.
Is it like a find the equation sort of thing?
Well, I'm not sure. I've probably done this problem, but it's probably been a year or so. So let's think about it. We're talking about a linear function. What's the most important thing about a linear function?
Wait.
What's the most important thing about a linear function or a line? It's slope.
It's intercept?
It's slope.
Maybe?
Actually, it's slope. I mean, the intercept is the second most important thing. But absolutely, without a doubt, the most important thing is slope. And especially from a precalculus viewpoint. Because as you get closer to calculus, you'll realize that calculus is all about slope. And the whole reason you've been studying slope for all these years in algebra and geometry and trig is because precalc is all about slope. So what is the slope of this line?
Actually, let's story. So y2 minus y1 over x2 minus x1, but you don't have...
Rise over run. That's true.
What?
So which 2 points are we going to use?
The third one? The 4,
For sure the third one, because it's got 2 numbers.
Yeah.
And we can use either of the other 2. In fact, maybe we'll use both of them, because we have 3 equations that give us slope. We can relate those 2. We can relate this one and that one, and we can relate this one and that one. So we have 3 possibilities, and all of them are going to give us a slope, and the slopes are the same. They have to be the same. The slope never changes on a line, no matter what 2 points you go between. It's always the same slope. So let's start out by the slope from these 2 lines. So that would be what? 18 minus b all over 2.
Yeah. So then...
What else is the slope? The same slope is 18 minus a all over 3. And the same slope is b minus a all over 1. Okay? So we now have 3 equations where m is the same in all 3 equations. So usually when you have something that's equal to something and then that same something is equal to something else, you kind of make it equal to one another. In other words, I can say that 18 minus b over 2 has to be equal to 18 minus a over 3. And I'll leave the third one aside for a moment just so I don't confuse myself. Now, does that help? I've got, if I multiply both sides by 6, what do I have? I have 54 minus 3b equals 36 minus 6a, or 2a. Aha! Now what I'm trying to solve for is that right there. So can I manipulate this equation to end up with this thing here in this upper rectangle on one side of the equation and a number on the other side? If I can do that, then I'll have my answer.
I think
we can too. And if we can't do it with these 2 equations, we can do it with the others. So let's see. I want to move the b to the right. So I'll have 3b minus 2a equals, move the 36 to the left, 18. And now, if I divide everything by 2, I got my answer. I got 9 there. I got 3 halves b minus a. 9. So I really didn't need the third point. Did I? Oh, yes, I did. Maybe. Yeah, I suppose I did. I only had to use 2 out of the 3 points to solve it. But it could have been a little tricky. In other words, I may not have gotten that solution from using the 2 that I did. It just happens that I made a good choice the first 2. Wow. These seem much harder to me. Did that seem hard to you?
Yeah.
I don't know if it's because
I wouldn't do that.
I've been off for 3 weeks or what, but that seemed pretty hard to me. All right, let's look at 13. But that's good. If you're doing reasonably well, we don't want to do just the easy problems. We want to work on the hard problems. If you were in the 50th percentile on the math, then we would be working on the easy problems. I'm a firm believer in that. Is we want to focus, we want to concentrate on where you most need help. And my guess is it's not the easy problems, maybe not even the medium problems. It's almost certainly the hard problems.
Yeah, if I could just get a couple of hard problems, it would help me.
Okay. So 13. First term of a sequence is 4.
Okay. Okay, -1. Wait, when it means even number, does it mean like the second term in the series?
Yes.
Or like a term that is an even number? Okay.
Yeah, it's a sequence. It's not a series, and the difference is a sequence is just a bunch of numbers separated by a comma. A series is always being added. So there is a difference between sequence and series. This is just a sequence. So the first number is 4. They tell you the second term is -4 because the second term is an even numbered term. So we get it by multiplying the previous term by -1. The next term is the third term, which is an odd numbered term. We're going to add 3 to the previous term. So what's our third term? Oh, they even tell you, -1.
Yeah.
Okay. What's the key to this problem? Since they ask about the 37th term.
Finding an equation, maybe?
Let's keep listing terms until we find a pattern of repetition, and then we'll know what the 37th term is. At this point, we don't see any repetition. But I'll bet if we keep going, it doesn't take long to find where it repeats. So what's the fourth term, which is an even term?
It would be 1.
Okay. What is the fifth term, which is an odd term?
4.
What is the sixth term, which is an even term?
-4.
We've found our repeat pattern.
Yeah.
So what is the 37th term?
Wait, so 6. Would it be 4?
Huh?
No.
Yeah. What's
Yeah, what?
Yeah, because the 36th term is always going to be this one right there, right? In other words, because 36 is an even multiple of 4, the ninth series, the ninth row here is going to end in that 1. And that'll be the 36th term. So the 37th term is the first term of the sequence, which is 4. It's a little bit like imaginary numbers. How much imaginary numbers have you had?
Only what we did last year in Algebra 2.
Okay, if you remember, let's just review this. I is equal to the square root of -1. I squared is equal to -1. I cubed is equal to -I. I to the fourth is equal to 1, and then it starts all over again. I to the fifth is equal to I. I to the sixth is equal to -1, and so forth and so on. So you'll frequently get a question like, what is I to the 501st power? Well, this is the sequence. I to the 501st power is going to be the first term of that sequence, because I to the 500th power is going to be the fourth term of that sequence. In other words, we want to divide that exponent by 4. Whatever the remainder is, that's the term that it is in the sequence. And this is something that you might even have to know for SAT. I've seen questions about imaginary numbers, but they always preface it with telling you what I equals. In other words, if they're going to ask you about imaginary numbers, they're going to start it off by saying I equals the square root of -1. Then they might say, what is I to the 501st power? And that's when you have to work out this sequence. But it is a 4-term sequence, just like our problem here. Oh, by the way, I apologize to David for me. He told me he needed to leave 5 minutes early, and I forgot all about it, and we went to the end.
Oh, he's fine. He was where he had to go.
I hope he wasn't late for where he had to be. But I space out. I'm lucky enough if I remember when the actual end of a normal session is. Okay, number 14. We have an equation of a line, y equals 3x plus 2. If the line M is the reflection of line L in the y-axis, what is the equation of line M? It's the first thing we want to do here.
Graph line L.
Okay. Where's its y-intercept?
2.
What's its slope?
3/1.
There's line L, and they're saying that M is a reflection of line L in the y-axis. So what is M going to look like? Where can I start M?
You can the y-axis.
Okay, so the same point is going to be on M. What's the slope of M?
1/3. I don't know.
If I draw the picture, now what's the slope of M?
-3/1.
Yes, -3. So what's the equation for line M?
-3x plus 2.
Right. And probably the most important thing for this problem is that's a slope of 1. Is that slope less than 1 or greater than 1? The other?
Greater than 1.
Less than.
Less than 1? Why less than
The
1?
flatter slopes are less than 1 because notice that I have to go up 1 and over 2, which is a slope of 1/2. So if I have slopes like this, that's greater than 1. And let's remind ourselves of why that has to be true. What is this slope? A horizontal line. What's the slope of a horizontal line? That's 0.
Oh, wait, horizontal is y equals x?
Well, it's 0. The slope is 0. A horizontal line has a 0 slope. So that's how I know that a flat line, a flatter type slope, is less than 1, is that it has to be between 1 and 0. Okay? And what is the slope of a vertical line?
Undefined.
Which means what?
That you can't do it.
No, it actually means it's infinity.
Oh, okay. I didn't know that.
Yeah. It's the only reason they'll call it infinity once you get to pre-calc and calc. They just don't like to use the word infinity in lower maths. And that's helpful to know that it's infinity and not undefined, because it tells you that any slope that's between 1 and vertical has to be greater than 1. In other words, this slope that I just drew there might be 2, might be 3. Obviously, the more vertical it gets, the steeper it gets. That might be 10. That might be 1,000. And finally, as you get vertical, you're doing rise over run. Well, the rise is infinite. The run is 0, so you're dividing by 0. Division by 0 means infinity. If I say y equals 2 divided by 0, they say you can never divide by 0, and you cannot. But notice that that approaches infinity. That is infinitely large. If I start looking at numbers, 2 divided by 0.1, that's equal to 20. 2 divided by 0.01 is equal to 200. 2 divided by 0.001 is equal to 2,000. Notice that as I make the denominator closer and closer to 0, my result goes closer and closer to infinity. So undefined really means infinity.
All right. Cool.
Yeah. All right. That's probably a good place to stop. I do have a 7 o'clock, so I don't have any leeway. I'll end your session early instead of David.
All right.
All right.
Thank
I
you.
will talk to you next Tuesday.
All right. Sounds good.
Bye-bye.